In this video, we will solve 5 questions related to kinematics. So it's going to be a little bit lengthy video, but please go through the entire video so that you can learn some new things or tricks to solve problems in kinematics. Okay. See the first question. If a car covers 2/5 of the total distance with v1 speed and 3/5 of the distance with v2 speed, then average speed is. If you get this type of problems, I'll tell you a generalized procedure in order to solve this type of problems so that if the values can be changed, even though the values are changed, you can easily answer the question. So we need to use the basic formula to find the average speed here. So let me write that average speed is equal to total distance by total time. Now, first of all, the car covers d distance. Finally, for suppose 2/5 of the total distance with one speed and 3/5 of the total distance with another speed. Let me tell you the total distance is for suppose d. So total distance is d. Now we want to find the total time. Now I am dividing the total time into two parts. One part is T1 and another part is T2. As we know that speed is equal to distance by time. So time T1 is equal to distance by speed. What is the first distance? 2/5 of the total distance. Here I assumed a total distance as d. Therefore, I am considering 2/5 of the total distance as a 2 by 5d. And it is covered with a speed of v1. Hence, it can be written as 2d by 5v1. Similarly, the time t2, because I divided the total time into two parts, now time t2 is equal to 3/5 of d. So 3 by 5 into d by v2. Now it is equal to 3d by 5v2. Okay. Getting to the formula, which is average speed is equal to total distance by total time. So average speed is equal to total distance is a d and time is splitted into two parts t1 and t2. Therefore t can be written as t1 plus t2. What is t1? 2d by 5v1. t2 is 3d by 5v2. Now from the denominator fractions you can take d common. So d by, if you take d common, you will get 2 by 5v1 plus 3 by 5v2. dd cancels out here and you will have 1 by 2 by 5v1 plus 3 by 5v2. Take the LCM for the denominator fractions. If you take the LCM for denominator fractions, you will get 5v1 into v2, which is 25v1 v2. And in the numerator, you will have 2 into 5v2, 10v2 plus 3 into 5v1, 15v1. It is divided with 1. When you flip the denominator, you will have 25v1 v2 by 15v1 plus 10v2. Okay. Now from the denominator, if you take 5 common, numerator becomes 25v1 v2. Denominator, if you take 5 common, it becomes 3v1 plus 2v2. Okay. Cancelling this 5 ones and 5 fives, you will have 5v1 v2 by 3v1 plus 2v2. If you use this generalized method, you will find any problem related to average speed easily. So the option is 5v1 v2 by 3v1 plus 2v2. So the correct option is D. Okay. Let's move to the next problem. Now the second problem. Here initial velocity u bar is given and the final velocity v bar is given, and it is covered with the velocity with the time t seconds. Means to change the velocity, the body took 10 seconds. We need to find the acceleration vector. So it is a very simple problem. First, we need to know that acceleration vector is rate of change of velocity. Rate of change of velocity means final velocity vector minus initial velocity vector by time taken. Now I am writing final velocity in point form as 2 minus 4 comma 5 minus initial velocity vector in point form 2 minus 2 3 by the time is 10 seconds. Now subtracting the corresponding components, you will have 2 minus 2 comma minus 4, and you have minus of minus plus 2 comma 5 minus 3, total divided with 10. Now it is equal to 2 minus 2 is 0 comma minus 4 plus 2 is minus 2, 5 minus 3 is 2 by 10. Now converting this into vector form, you will have minus 2 by 10 j bar plus 2 by 10 k bar, because I component is 0 here. In that case, you can write this as 2 ones, 2 fives, 2 ones, 2 fives. Taking 5 common, you will have minus j bar plus k bar by 5. So this is the acceleration vector. If you know that acceleration is a rate of change of velocity, this problem is a very easy problem. Okay. So second option is D. Let me move to the third problem. So this is the third problem. A car moving with constant acceleration covers the distance between 2 points 180 meter apart is 6 seconds. Means the car is moving with uniform acceleration. It covers 2 points, and these 2 points are at a distance of 180 meter, and the car took 6 seconds to cross these 2 points. Its speed as it passes the second point is, means here the final velocity is given, which is 45 meter per second. We need to find the acceleration and its speed at the first point. To do this problem, we need two kinematic equations. Okay, so first kinematic equation is v square minus u square is equal to 2as, because the distance between the 2 points given and one of the velocity given. Therefore, I can substitute 45 in place of v, because its speed as it passes the second point is 45 meter per second. Therefore 45 whole square minus u square is equal to 2a into s is 180. Okay, now what is 45 square? So the square of 45 is 225 minus u square is equal to 2 into 180 is 360. So 360a. Consider this equation as first equation. Now I am going to write the second equation, which is equal to, which is nothing but v is equal to u plus at. Okay, v is already given, which is 45, and u we don't know, and a we don't know, but t is given as 6. So 45 is equal to u plus 6a. Okay, from this I am writing a as 6a is equal to 45 minus u. A is equal to 45 minus u by 6. This is a. Consider this as second equation. Substitute second equation in first equation. In first equation, if you substitute, it becomes 2025 minus u square is equal to 360 into, in place of a, 45 minus u by 6. Now 6 ones, 6 sixties. Okay. What is the product of 60 and 45? 45 6 is 27, and you have 0. It is 2700 minus 60u. It is 2025 minus u square. Converting this into a quadratic equation, you will have u square minus 60u, 2700 plus 2700 minus 2025 equal to 0. Therefore, u square minus 60u, 2700 minus 2025 is 675 plus 675 equal to 0. If you take the factors for 675, I can consider 45 and 15. Okay, so 45 into 15 is 675, and 45 plus 15 is 60. Hence, I am splitting the middle term, u square minus 45u minus 15u plus 675 equal to 0. Okay, now I am taking u common from the first two terms. You will have u into u minus 45, and from the third and fourth terms you can take 15 common. U minus 45 is equal to 0. Therefore, the quadratic equation becomes u minus 15 into u minus 45 is equal to 0. You can have two options. One is u is equal to 15 or u is equal to 45. But u cannot be 45. Why? Because when you substitute this u in a second equation, you will get acceleration as 0. But you have some acceleration in the options. Therefore, you can consider u as 15. If you consider u as 15, acceleration a becomes 45 minus 15 by 6, which is 30 by 6. So the acceleration is 5 meter second power minus 2. And the initial velocity we want to find, initial velocity u is equal to 15 already we found. So the correct answer is fourth option. Okay, so initial velocity is 15 meter per second, and acceleration is 5 meter per second square. In this way you can solve this third problem. Okay, let me move to fourth problem. If the particle is moving along a straight line by the relation s is equal to 2 minus 3t plus 4t cube, where s is in centimeters and t is in second, its average velocity during the third second is. Here we want to find the average velocity. In order to find the average velocity, we need to know what is the net displacement by time taken. Net displacement by time taken. Here time taken is 1 second, because whether it is a third second, fourth second or 100th second, the time interval is only 1 second. Therefore, t is 1 second. But we need to find what is the displacement covered in a third second. In order to find the displacement in a third second, we need to find the total displacement in 3 seconds and subtract from it the displacement covered in 2 seconds. Let me write S3. So S3 is nothing but displacement in 3 seconds. Displacement in 3 seconds, not third second. Displacement in 3 seconds. Okay, in order to find the displacement in 3 seconds, we need to substitute a t as a 3 in the given equation. Substitute that. It is 2 minus 3 into 3 plus 4 into 3 cube. It is 2 minus 9 plus 3 cube is 27. 27 fours. 27 force is 108. Okay, now its value is given by 108 plus 2 is 110. 110 minus 9 is 101. This is the displacement in 3 seconds, not third second. And we want to find the displacement in 2 seconds. So S2 is nothing but displacement in 2 seconds. In order to find that, we need to substitute the t value as 2 in the given equation. Therefore, it is given by 2 minus 3 into 2 plus 4 into 2 cube. It is equal to 2 minus 6 plus 2 cube is 8. 8 fourths is 32. 32 plus 2 is 34. 34 minus 6 is 28. Okay. I want to find the displacement in third second. Therefore, S third is equal to S3 minus S2. It is equal to 101 minus 28. 101 minus 28 is 73 centimeters. Okay, therefore, average velocity is equal to displacement covered in third second, which is 73 centimeter, by time. Time is 1 second. So 1 second. Therefore, it is equal to 73 centimeters per second. In this way, we can solve this problem, and the correct option is A. Let's move to the last problem, which is a fifth problem. A particle starts moving from rest with uniform acceleration. It travels a distance x in the first 2 seconds and a distance y in the next 2 seconds. Then what is the relation between y and x? So as the particle is starting from rest, we can consider u as 0. And it travels distance x in the first 2 seconds. Therefore, we know that s is equal to ut plus half at square, but it is starting from rest. Therefore, u is 0. When u is 0, first term is 0. You can have s is equal to half into at square. Now for first 2 seconds, it travels a distance of x. Therefore, in place of s, we can substitute x, and in place of t, we can substitute 2 seconds. Now x is equal to 1 by 2 into a into 2 seconds square is 4. Therefore, it is 4. 2 ones, 2 twos. Finally, x value is 2a. Now what I am doing is, in the next 2 seconds, it travels a distance of y. Now what I am considering is a total 4 seconds. In total 4 seconds, the object or particle travels for a distance of x plus y. And here again u is equal to 0. Therefore, using this equation, s is equal to half at square. But now I am considering the distance as x plus y, and the time must be considered is 4 seconds. Therefore, in place of s, we can take x plus y, which is equal to half into a into time is 4, which is a 4 square. 4 square is 16. Now 2 ones, 2 eights, which is equal to 8a. We got two equations now. X is equal to 2a and x plus y is equal to 8a. We just want to find the relation between x and y. For that, what I am trying to do is, I am subtracting first equation from the second equation. So 2 minus 1, it implies x plus y minus x, which is equal to y. 8a minus 2a is 6a. Now I got y is equal to 6a, and we already know that x is equal to 2a. It implies y is equal to 3 into 2a. Because y is equal to 6a, I can write y as 3 into 2a. In place of 2a, we can substitute x. Therefore, y is equal to 3x. So the option is y is equal to 3x for this problem. Okay, C is the option. Thank you very much for watching this video. If you really like this video and think that this video is useful, share it to your friends. Subscribe to my channel. Thank you very much.